Hola, Mr. Lee here. All right, we're going to get some practice on exponential and logarithmic applications. So we have some word problems basically. Most of these will be given some type of equation with different variables. Depending on the context, on the situation, we'll have to set up the equation in a specific way and then solve for a given variable. Okay, so let's get into it. This first one, it says, of all eligible voters in your country, 70% are currently registered to vote. V is going to be the percentage of all eligible voters. T is the number of years from now. And here's our function, okay? So it's asking, in how many years will 80% of all eligible voters in your country be registered to vote? Okay, so we have the variables labeled for us. Okay, so let's kind of backtrack here. It's asking, in how many years will 80%? We'll stop right there. Okay, analyze what we're being asked. 80%, right? If we go back to the variable descriptions, V is your percent. Okay, so you can already be thinking, okay, I'm going to replace this V with 80, right? Because it represents the percent. So really we're asked, in how many years, right? In how many years will this 80% happen? So we're solving for this unknown t variable, okay? So let me rewrite this whole equation first, and I'll show you how you can set this up. But really in the end, once we substitute some known values, we're just solving a either an exponential or a logarithmic equation. I think it's an exponential equation, but then we might use logs to solve it, okay? All right, so we said 80% of the voters is what we know, right? So I'm going to copy all this. I gotta let you see the whole process. I'm going to change this to 80, right? Because that's what I know one of the parameters is. So 80% goes into the v value. And if you look at this, we actually only now have one variable to solve for, right? Which is your t. Okay, don't confuse e with like a variable. It is a letter, but if you remember, it's our constant number, okay? Related to your natural log. So really, your only variable is t, which is what we're solving for. We should be able to do that. Okay, so let's go ahead and solve this. We've had some practice on solving, so I might go through this quick, but you guys can pause and rewind the video as you need to. Okay, so I'm going to first get this exponential term by itself. Okay, so two things. I got to subtract 100 on both sides, and then I'm going to divide by negative 30. Okay, so subtract 100 on both sides. We get negative 20 here, and then the rest of this guy. And then I'm going to divide by a negative 30. All right, I'll show you the work here. If I do a negative 20 over a negative 30, simplifies to a 0.6 repeating. I'll leave it as a 2/3. Okay, so I will kind of simplify as we go. So negative 20 divided by negative 30 is a 2/3. All right. So we're going to get a 2/3 over here. And then just this piece. Okay, so we successfully isolated your exponential term. And now we convert from exponential form to log form. Okay. So I'm going to write this as log base e first. Log base e of 2/3 is equal to negative 0.04t. Okay, so follow your around the world method, exponential form to log form. Same base. Follow your order around the world. E to the power of negative 0.04t is equal to 2/3. That's exactly what's written here, right? E to the power of negative 0.04t equals the 2/3. Okay. So with this, I like to start with the log e and not skip some steps, but hopefully you guys know your log base e is just your natural log. So I can replace log base e with just natural log of 2/3. Okay, so that's what we're going to do. Okay, home stretch, divide both sides by negative 0.04. And that is what t equals. Okay, let's go back to the submission of the answer. Give an exact answer expressed as a natural logarithm. Okay, so it's not asking us to round, so we're just going to copy all this, and it should work. Okay. So if we wanted to, we can figure out, what the estimation is. It's about 2.13 years, right? T is in years. But then they want the exact answer, so we just kind of copy and paste. All right. All right, let's do the next one. So, bacteria in a petri dish culture are self-duplicating at a rapid pace. Relationship between the elapsed time t in minutes, number of bacteria, b of t, modeled by this equation. Okay, let me enlarge this a bit. So let me start by writing the whole function again. B of t equals 10 times 2 to the power of t over 12. Okay, so we are seeing a times 2 here because the bacteria is doubling. So duplicating nature to it. Question, how many bacteria will make up the culture after 120 minutes? Okay, so how many bacteria, this is the number of bacteria, B of t, that's your output, will make up the culture after 120 minutes. Okay, so hopefully you'll see that this is one of the easier types of questions because they're giving us the t variable this time, right? We want to figure out how many bacteria there are after 120 minutes. So your t is going to be converted to 120. So really, I'm just doing this, right? B of t equals 10 times 2 to the power of 120 over 12. Right? We're solving for how much bacteria, and the way the function is written, it's already isolated. So we just need to evaluate this, right? Which we'll do with the calculator. Let's see. Round your answer if necessary to the nearest hundredth. Okay, so let's actually figure out what this is. Right? It's going to be 10,240. No need to round. Interesting how they said round to the nearest hundredth. Let's see. Maybe we're doing something wrong. Let's see. Okay, we're good. Not sure why they asked the round. Maybe it's just a general set of directions. So there'll be 10,240 bacteria after 120 minutes. Okay? So that one we didn't solve for an unknown variable, right? Because your output value or the number of bacteria was already isolated, right? So it depends how your function is written. Okay, let's keep going here. Use what you need. I'm going to do 4 problems total. But hopefully you guys will get the idea behind how these are structured. All right, so Katya is a ranger at a nature reserve in Siberia, Russia. She studies the changes in the bear population over time. Okay, so T is in years. Bear population is the B of T. So it's another population question. Okay, let me copy this over. Bear population, B of T, is equal to 5,000 multiplied by 2 to the power of negative 0.05 T. Okay, so just a little bit of review on, how these exponential equations are written in its general form. This is your initial population, so there should be 5,000 bears. And then it looks like we're multiplying by a 2, so there's some doubling nature to it. Okay, so growth rate, 2, and then initial value, 5,000. So let's see what they're asking. In how many years? I'll just stop right there. Okay, I'm not going to finish the whole thing. You guys can read it yourself, obviously. But when I see that, in how many years, I'm already thinking I have to solve for time. Right? In how many years? Years is a measure of time. So I'm already solving for this t value. In how many years will the reserve's bear population be 2,000? Okay. So how many years will it be 2,000? So I'm going to replace the population with 2,000 because they're asking when will it actually reach that. Okay. And then we'll have 5,000 multiplied by the rest of this. And we're solving for t, right? Once I fill in that 2,000, it replaces the b of t, and then the rest of the equation, you just see one variable, which we're solving for. We're solving for t. Okay? So, again, we're going to solve this. We're going to isolate your exponential term, convert it into log form, and then we'll go from there. So first thing I need to do is divide both sides by 5,000. So what is 2,000 divided by 5,000? 0.4. We'll leave it as a fraction. Okay, so 2,000 divided by 5,000 is 0.4. So the left side turns into 0.4. 5,000 goes away on the right side, and we're left with your exponential term. Okay, so let's convert into log form now. I'm going to start with my log. Same base as your exponential term. So log base 2 of 0.4 is equal to negative 0.05t. Okay, so I know I go through it quick, but always double check your around the world method. Okay, you can even write it wrong and check it and then make an adjustment. Okay, so let's check it. Base is 2. Base is 2. 2 to the power of negative 0.05t is equal to 0.4. Is that what we had in the previous step? Right? Because we're assuming our previous step is correct. 2 to the power of negative 0.05t equals to 0.4. That's the order I want. Okay, so this is good. Okay, so we're going to now divide both sides by negative 0.05t, and we're good. So divide by negative 0.05. That's what your t equals. Let's say if they want a rounding, round your answer if necessary to the nearest hundredth. Okay, so we do need to evaluate this. I'll just copy this over, get the calculation from Desmos. 26.4385. It says to the nearest hundredth, so that is 2 decimal places. So we're going to go 26.44. So for 26.44 years, bear population will reduce to 2,000, it looks like. There we go. Okay, last one. We have a glacier context here. Huge glacier covered an area of 45 square kilometers. Changing weather patterns. The area begins to decrease exponentially. Okay, so the variable A is the area of the glacier in square kilometers. T is the time it takes for that area to change. Okay, so let's rewrite this. Area equals 45 times E to the power of negative 0.05t. Okay, so make sure you know it's 45 times E. There's an invisible multiplication symbol. Okay, 45E to the power of negative 0.05t. Okay, I'm going to read the question. How many years? Pause. You can already think, hey, they're asking how many years, so you're solving for t. Okay? How many years will it take for the area of the glacier to decrease to 15 square kilometers? So they're giving us the area is 15 square kilometers, so that means I can replace this a value with 15. Right? Then we have an equation, again, with one variable to solve. All right, so let's finish this up. This might go quick, but pause as you need to. I'm going to divide both sides by 45. 15 over 45, I think, is a 1/3, right? Divide both sides by 45. So the left side turns into 1/3. We'll write it in its simplified version, and then this will be e to the power of negative 0.05t. Okay, so we're ready for log form. Some of you guys might be thinking natural log, which is great. I'm going to really be thorough here. I'm going to start with my log base e, which is the same thing as a natural log. Log base e of 1/3 is equal to negative 0.05t. Okay, double check your around the world method. Make sure you have the right order. Start your base of the log. E to the power of negative 0.05t equals 1/3. That's what we have written here. So we're good. Okay, divide both sides by negative 0.05. Just negative 0.05. And then that'll isolate t. Let's go back to the directions. Make sure you read these carefully. Give an exact answer. Express this natural logarithm. Okay, so they just want this. I'm going to now change the log base e to an ln. Okay, so we know that if you have a base e, it's the same thing as saying natural log, like that. So this is what we want. Khan Academy might accept if you do log base e, but let's just not try it. We'll just type in the natural log like this. Okay, log base e, same thing as natural log, so we should be good. There you go.